Good afternoon, everyone. Welcome to another session. My name is Nick Berente. I'm with the University of Notre Dame.
I'm Susan Winter. I'm at the University of Maryland and the College of Information Studies.
And I'm Joel Cutcher-Gershenfeld at Brandeis University at the Heller School for Social Policy and Management.
And I'm John King at the University of Michigan School of Information.
And actually, Nick, I think the video didn't start until your intro, so you get to introduce yourself again as you do well, actually, we're going to do first the video, right?
Right. We're going to do the first video. Are you ready for that?
Yeah. As always, we start with a short video. These have been developed for this series. They're all available for reuse on our website, and I'm delighted to begin with the first one now.
Making the leap from a small scientific project to a large NSF science and engineering initiative is a considerable undertaking.
Actually, it looks like it's not running.
It is. Yeah, it's not running the video portion.
Yeah, so I'm going to start again.
Scientist Lucy, for example. She does computational chemistry and is making the leap to large. Lucy has identified her stakeholders and the value propositions that her project offers them. Lucy has also generated impact metrics that match the diverse interests of her key stakeholders, tracking intellectual merits and broader impacts. Lucy is becoming a project leader. She must be a data leader. That starts with data management. Lucy knows data, models, and software are vital to her being a leader in her field. The data management plans for her small and medium grant proposals promised data would be available on request. There were few requests. Now, journals ask her to provide data when she submits articles for publication. This is for reproducibility, but more is going on. Lucy recently heard about FAIR data, data that is findable, accessible, interoperable, and reusable. She is embracing a disruptive idea. Fields and disciplines that are fair with data will progress faster. As a leader of a large science and engineering project, Lucy is now committed to make her data, models, and software available for use by others. She knows that she can get credit when others use her data. A DOI, Digital Object Identifier, attached to the data makes credit easier. Lucy can specify an embargo period so her team can mine the data first. These aspects of data management move Lucy toward data leadership. True data leadership comes from Lucy's understanding of the role of data, models, and software in the transformation of science and engineering research. Data research requires aligning diverse stakeholders and forging the high-impact culture needed for large-scale impact. So, let's focus on what you need to do to become data leaders.
Super.
Yeah, so this afternoon, as you can tell, our primary focus is going to be on data management. And just to point you to where we are in the series of sessions that we're doing, we've gone through 4. We of course introduced the topic. We got into stakeholder alignment, measurement and feedback, and last week we talked about leadership. Today we're talking about data primarily, and we're going to start with our panel. So we're switching things around a little bit. We have some wonderful guests, panelists, and then of course the next couple of weeks we're going to be focusing on workforce issues, and in the final session we're going to focus on collaboration.
Super. Thanks, Nick. I'm sorry I skipped around there for a moment. As we get started, first, we'd always like to start with your feedback. We're delighted to hear from 170 of you on the survey before this session, pre-session survey. Just as a heads up, we're only going to do one more survey. We're going to cover the topics of both sessions 6 and 7. We know that you're getting some survey fatigue, and so we've combined them into one concluding survey that will go out on Wednesday. But for now, as you said in the survey, you are in our sweet spot. Most of you have led either small or medium projects under $2 million, either 1 to 2 or 3 to 5 of them. A few of you have had 1 or 2 larges, most of you have had none. And this is, in a sense, where this seminar is headed. Many of you were at session 4, but those of you that weren't, a number of you will be watching the video. And about half of you said that you would be going back and be looking at some of the earlier videos. And a couple of you liked the choice of "It's Complicated." But just as a quick sum up from the last session, all of you, or at least a very high percentage of you, appreciated what Nick told us about mission, vision, and goals. You really liked Coach McGraw, also the idea of enterprise leadership. Sherry Lassiter as president of the Fab Foundation, and Neil, and the fact that they both came in as a tie in your preference will be an issue of discussion between the two of them, I'm sure. And there were a couple of other things. Kathy White and Representative Bill Foster were all, at least about a third of you, as things that you found valuable. And by the way, we did ask you about your fields and disciplines. About half of you that took the survey are in computer science, and many of you in engineering, data science, and information science, but then a wide range of other fields and disciplines. And of course, we don't know how fully representative this is of all of you who are on the call, but that just gives you a sense as to who's responding to the survey. And with that, please allow me to invite you now to a panel discussion. We have a lot to say, as you'll hear from Susan, about putting together data management plans and understanding their importance in society, and from John about the broader challenges of data leadership, and from Casey on terms of her pioneering research, as she'll tell you, as a data monk. But first, we wanted to actually begin with, you might say, the work itself. And so I'm going to stop sharing the screen in a minute, but I'm pleased to introduce you to our 3 panelists. Christine Kirkpatrick works with the San Diego Supercomputing Center. She's an extraordinary leader helping folks access and utilize what we call big data. Steve Diggs is at the Scripps Institution of Oceanography. As we'll soon hear, he does data work, but on a ship at sea. And Kirsten Leonard, who's at the Lamont Doherty Earth Observatory at Columbia University, is going to be part of this conversation initially around the use of attaching digital identifiers, getting data from physical samples. But then we're going to pull the lens back with all 3 of them and talk about some of the broader changes in the landscape with data. So I'm going to stop the screen share because it's important for you to actually have the spotlight on each of them as they speak. And I'd actually like to start, Christine, with you. People come to you, researchers, who want to use what we call big iron, supercomputing capabilities. But tell us a little bit, pull the curtain back about the work itself as a data professional.
Sure, thanks, Joel, and thanks for having me here. I've really enjoyed this series. So some people are scared off by our name when I say I'm from the San Diego Supercomputer Center. Sound like I'm full of myself. And of course, supercomputing's our brand, but we're really about advanced computing. And even though everything I do is infrastructure based and a lot of acronyms, we all are very motivated by helping with the time to science problem, helping researchers spend their time on research, not on IT issues. And then also ensuring that any data that is created or transformed is left in a state where people can use it and reuse it to unlock answers that the original people who produced that data might not even have been looking for. So of course, what we do around at an advanced computing center and around the big machines, it's a lot of storage at scale. It's very different to keep track of all the data on your own personal laptop versus, say, a petabyte of data. It takes very different techniques. So you could almost say that we specialize in organization at scale. But that said, because we do research computing, we deeply care that it's data, that it's not just, a large scale storage resource. Or I've heard people describe HPC centers as sawmills. You bring us the trees and we'll give you boards. So that's what I do, is I care deeply about what's going through that sawmill. So we worry not just about FAIR, like you had in your video. We worry about trust, that you hear a lot. It's an acronym that NIH has used in some of their solicitations. And then, of course, the newer CARE principles, which is about Indigenous data governance. We also worry about how do you store this data in different types of databases. So what things are appropriate to, say, data text mining versus creating large graphs? And when is it appropriate to stay in SQL, because that's what researchers are used to using, or when you want to go to something that's unstructured data. And then some of the newer things that we've been working on as part of this HPC ecosystem is, what are the new challenges with storing and managing data as it relates to machine learning and AI? Because that brings up a whole new host of reproducibility questions. So maybe I'll stop there and give others time.
No, that's a great beginning of the conversation to sketch the landscape. In a sense, I'd like to continue it, but with Steve talking about the same story, but on a ship at sea. And I don't know if you want me to show the picture then.
Sure, go ahead.
Okay, this is just to get us in the mood for the conversation. I'll put it.
So as you can see, tongue in cheek, it's, easy to acquire these data and they're rather inconsequential. It's just that, climate change may take us all out. So these things don't have to be carefully measured. And of course, measuring things at sea is like measuring things in space. It's a hostile, low bandwidth environment that needs stable technology. But just like Christine was talking about, a lot of what we do is based on the philosophy that many of us go to sea with, which is there's a rugged individual component, right? All of the software, store all of the data yourself. Never let it out of your control, because it really is your competitive advantage. And so these things work counter to FAIR, not because there's nefarious individuals that are trying to go backwards, but just because this is a very oldish exploration-based culture, where the technologies that of interest really have to do more with the sensors at sea. And we're also in an interesting time, as Christine alluded to, with many other things. We are in the midst of sort of a robot takeover, where there are a lot of remote autonomous devices that are pumping out data at unprecedented volumes. And the people at sea are transitioning part of their job into one of calibration and validation, more than just providing the basic data. It's a small data set by nature, almost everything we do, even the underway data. And so trying to bring in big data techniques and big data machinery isn't appropriate yet.
Super, I appreciate that. And as we change and look at data in context, Kirsten, I wonder if you might even talk about the fact that now people are attaching data to physical samples. And if you want me to show the IGSN picture at some point, let me know.
Yeah, again, wanted to say thanks as well for the opportunity to actually talk about that. And I wonder how many of the participants in this webinar actually deal with physical samples. But it is ultimately, a fundamental component of research in the earth sciences, in the environmental sciences, and life sciences. Everybody generates data by studying physical samples, and that can be anything from a little ant or a bat that was collected in the woods of a Pacific island to rocks collected from volcanoes and so on. And these samples are an incredible resource for research, but they aren't well shared, and that was a driver for us years ago, and Joel was part of that effort, to think about how can we better make the connection between the physical world and the digital world. We need to identify uniquely every sample so we can relate the data to that sample without any doubt. And that was, it just reminded me the way Steve talked about that community, very much so of what we are still dealing with. It's a community that generates small data, that feels a lot of ownership of their own samples and of the data generated from that. And I do think that our leap to the large really was the recognition that we couldn't waste these resources. We needed access to it. And Joel, do you have the slide?
I do. Kirsten will tell you that she developed this IGSN, this DOI for physical samples. And you want to tell the story of this?
Yes, so it was part of this research coordination network that we started in order to bring the community together. And one of the points of discussion was really who owns samples specifically from dissertations, from graduate work. And some of the graduate students who were part of our workshop basically said, we don't really have control over what happens in the lab. It's our professor who tells us what to do. And they were enthusiastic about moving on into a new world of physical samples, getting digital identifiers that would make them unique. And one of the students basically presented this slide. I'm still very enthusiastic about it, to say, our professor wasn't happy about the idea that everything needed to be registered with the DOI.
Super. And actually, I'd like to use that as a segue to then talk about, a specific field, the geosciences, which a number of years ago launched EarthCube as an attempt to really transform the science itself through data. I'll start with Steve and Kirsten. You were there at the founding. And Steve, you want to say a little bit about the NSF? The initial strategy was to build it and hope they'll come. And then they realized there were some end user issues that needed attention. Do you want to say a little bit about that?
Sure. I mean, it was an ambitious initiative in the beginning. Kirsten and I were there in a room of 200 people at least, data professionals from all walks, and a really fast start out of the blocks to solve everybody's problem without a real careful consideration to where people were in their data life and where things were in the data life cycle. And each domain and subdomain needs something a little bit different, a little bit more tailored to it. And that's something that EarthCube learned over time and has evolved to address.
Well, and I'm going to come back to Kirsten in a minute, but let me go to Christine, because you're now what we call the backbone organization for EarthCube. So bring us up to date. What is it like being part of the infrastructure for data in an entire field?
Sure. Well, I feel like it's an important distinction, especially for EarthCube, to say that it's community governed. And so the backbone organization really is that. We back up the ideas and the energy and the momentum of everything that's going on in governance. So we can't take credit for everything. But EarthCube has really found a niche in fair data for the geosciences, and it's specifically not just that we all agree on the philosophy, but that we agree, let's move past that and come up with practical steps. So I hope it's not too shameless to plug our annual meeting, which will be June 15th through 17th. But you'll see some interesting discussions there. We will have a talk on fair workflows. And those who have registered enough in advance will get some physical materials, because we know everyone's been missing swag and going to conferences. But one of those things will be a postcard that simply breaks it down. Where do you put your data? Into something that you can hold in your hand. And so they're very complex things, but we've tried to take all the best advice and distill that. Another example is that our leadership council and other interested folks came up with EarthCube specifications for data and software. And it's not very long. And one of the services that we provide to funded projects in the EarthCube portfolio, although honestly, any geoscientists who asked for it, we'd work with you. What do I do with GitHub, right? Is what things should I have on my website about data and software citation? Just things that we all want to do, but we try and provide the couple steps to just get you started.
Super. And I'm going to ask one more panel question, and then we'll go to Nick and Susan to see if there are any questions that we're hearing from the audience. But Kirsten, a missing piece of this conversation are the publishers and the funders. I wonder if you could take us back to the Openness initiative, which actually had a remarkable breakthrough a year ago, a little bit more, in terms of eliminating data supplements. Could you tell us kind of in short that story?
Yeah, very quickly. I mean, the recognition was really among those who are actually representing data repositories, trying to make data available, that the way data were published was just not appropriate. Data were not available. They were not completely included in publications and so on. And it was really the recognition also that in order to change a culture, you have a carrot and a stick, and you can do a lot of carrots through, software tools, through making things easy, but the publishers have a bit of a stick. And so we started to work with the publishers to implement some guidelines, author guidelines, how you should be dealing with your data. And after a few years, we actually got to a statement of commitment where publishers and the data repositories jointly signed a set of commitments for fair data, making sure that data in publications actually goes to repositories, preferably to those that are domain specific, and curate data in the most community-driven way possible. So it was a big success in that. I mean, I run a data repository myself. Since these guidelines were implemented, the data we receive has more than doubled.
Wow. At the very end, I might ask each of you for a piece of coaching advice for researchers who are maybe discovering that people are like you are their new best friends. But before we do we have some questions in chat, either Susan or Nick, that you want to pose to the panel?
Sure. And there are a number of questions in Q&A. One thing that I just noticed, how do you handle large amounts of transient data? The data that's not stored, it's gone forever. Meanwhile, it's not clear the data has any value. How do you decide whether to allocate resources for storing and analyzing the data, even before you know if the data is worth saving? So
Steve, you probably live in that world.
Yeah, we do. We have, so when we put instruments in the ocean, there's sort of a high frequency capture and a sort of a lower frequency data that come out, decimated data. And until recently, those data, since they're so voluminous, gigabytes, which used to be a lot, they were lost. And it turns out that they were valuable. So I would say, in direct response to the question, take a 5 to 10 to 20 year view in the future and think about reconstructing the science, to use that as a bar to see if those data are worth keeping. In most cases, along with Moore's law, the answer is yes.
And that raises, I think, an important point, that data professionals at one time were seen as, in a sense, plumbers, infrastructure, secondary, but increasingly people like yourselves are full partners in the research enterprise, because what you know about the data workflow is in fact instrumental to the actual conduct of the science itself.
Well, the other part of that is that so let's say the chief scientist involved will have a set of priorities that their remit demands that they pay attention to. The data professional can look at across domains and look at trends and bring other priorities to the table. So it's a good consultant role to work with the rest of the science team.
I'm mindful of time, and I know Steve also has to leave momentarily for another meeting. Do we have time for one more question?
So, and let me just make a quick note. If we can have a quick question, there are a lot of wonderful questions online or on the Q&A. And if the panelists stick around, I know, Christine, you've been answering a few, so thank you. And if you want to go in the Q&A and answer some, we won't be able to ask them all live. Perhaps something you can reflect on. It looked like kind of a fun question. My institutionally moved away from Box free and unlimited, to Microsoft SharePoint limited. Calculation so short, storing the data will have 100 terabytes. AWS costs almost as much as a grad student. Any guidance? So I guess the question is, any reflections on all of these different commercial kind of cloud-based platforms?
Sure. Again, at the risk of seeming shameless and self-promoting, I hosted a webinar last Thursday for the Open Storage Network on this very topic. And we had different speakers. Ed Lisowska from the University of Washington gave a topic called "Don't Be Stupid, Use the Commercial Cloud." And then Ryan Abernathy from Columbia, he had a slide in his talk following that said, "Don't be stupid, use the commercial cloud except for data storage." And we looked at the costs, and they are great. And so on the Open Storage Network, we've been trying to come up with a way that institutions can host a storage pod locally and then utilize commercial cloud for compute or exceed, the exceed, soon to be called access resources, the NSF national facilities. Storage is a great moneymaker. It's like the mini storage that you have all over town, at least sprinkled all over our town, because you put your stuff there and you leave it, and then you're paying the monthly fee. And the cloud providers know this. And I think this is where a lot of their income comes from. I'm on an NIH project, and we looked at AWS versus Google Compute Cloud. And it's like there were a few quibbles, and they keep leapfrogging each other, kind of like the AT&T MCI thing, if you remember, for when we used to have long distance plans. It's the storage that gets you. It's not the compute time on almost all projects. So again, if you're an NIH researcher, they're going to have you go to commercial cloud and you're stuck, but they do have the STRIDES program, which helps to pay for those cycles. If it's just for your own, the cloud is really convenient. You've got, multiple copies out there and you won't lose it, but on-premise is still the lowest cost.
So we're literally at time, but maybe Kirsten, you could lead us off in 1 minute. If you had to give one piece of coaching advice to researchers, then we'll go to Steve and then Christine. You each have a minute to give us a single point observation or lesson. Go for it.
I really think in this context about the reusability of the data, and you want to have impact with your data besides just your publications. So in that respect, you need to make sure that any data you make accessible to others can be interpreted, can be evaluated, and that requires some curation that data repositories can provide. So just putting things in the cloud to me is one step to ensure preservation, but to ensure reusability, you need to do a little more.
Super. Steve, last word.
Yeah, I'm going to reiterate what I said before, is to think about the future, but I think it's appropriate to quote a Spike Lee movie here. It's always the right time to do the right thing. And you have to think about others who will follow in your wake, and make it as easy as possible for them to do their work, because you can make it really hard for them to do their work with not much effort.
So we work today for the next generation. Thank you. Christine, last word.
Yeah, I've got 2 bumper stickers. The first one, don't let the best be the enemy of the good. Add some metadata to your data. Just commit to sharing it. Doesn't have to be perfect, but get it out there. And you'll get better as you do it, or your team will. And the second one is, and I'm going to mess this up, but none of us are as smart as all of us. So you're all smart people, all of you. And some of you might feel awkward asking questions. Don't. You can, consulting and asking for quotes is usually free. Approach people like me and ask questions. No one knows every answer to everything about data and infrastructure. We're all trying to figure it out together.
Super. Please join me in a round of virtual applause for this panel. We really appreciate the way that you've led us into the conversation on data and data work. At that point, let me now, besides again saying thank you, turn it over to Susan, who's going to take us more into data management. The floor is yours, Susan.
Thanks, Joel. So we're going to talk a little bit about data management, and next slide. But keeping in mind that we're not just talking about data, that there are also models and software that are being shared. And so many of the things that we're talking about in terms of data management also apply to models, to software, and of course to metadata and documentation. And you already know a lot about the stated goals, about FAIR, about trust, about care. Nobody's mentioned security, interestingly, which is another thing that you probably also should be thinking about. And that data, we're trying to make it shareable upon request and also upon paper submission. Next slide. But the question is, how does this work in a large? The real difference here is that you need to actually work together to develop agreements among a larger group of researchers. So this means coming to agreement on standards and protocols about types and sources of data, about shared governance, about DOI for credit allocation. It means agreements on accountability. Who's going to be accountable for collecting, storing, archiving, and curating? Who's going to be accountable for manipulating, analyzing, and documenting? Who's going to be accountable for interoperability? And also agreements on reusability. So openness, repurposing, recombining in innovative ways, how you're going to pull these things together, work on them, and at the end of the project, what you're going to do about sustainability. And this is challenging. This is not just a tick the box exercise. Can you go back, Joel? Because in previous workshops, when we've gotten to this slide and we've had people actually start working on these agreements, very quickly, the participants realize that what they're working on is how to be a team. Working through these agreements and determining who's going to do what is a really important part of preparing your team to do the science of it. And by the way, the answer, we're all going to be jointly responsible, is the wrong answer. Because if everyone's responsible, nobody's responsible. So you need to actually decide who's doing which piece of this. Next slide. And getting this part right means improving the science, but can also have important impacts in terms of workforce and economic and innovation. Partly, it's important to recognize that nobody as a PI actually can do all of this. That's the point of bringing in the panel and the speakers that we've got. You're not going to do all of this. You're going to be responsible for making sure that it gets done. But the message here is that there are experts who know how to do this. There's guidance available. Christine is running webinars for you. These are resources and support structures that can help you in doing this. But first you have to know that you need to do this. Next slide. So why? The underlying argument for data sharing is that it will move the science forward. And if we can move the sciences from data poor to data rich, the argument is that we can make faster progress. Some areas of science are particularly data poor, some are particularly data rich, some are moving from one to another. And there are some examples of moving from data poor to data rich in ways that have really moved science forward. Next slide. For example, here's a brief and incomplete history of genetics. Genetics realized early on that they made progress faster if they could pool data to overcome the limitations of small sample sizes. So if you're looking at an uncommon genetic anomaly, if you've only got 6 people, you don't really have a large enough sample size. But if you have 6 people and another 100 researchers have 6 people, suddenly you've got a sample size of 600. So there are real advantages to sharing. And interestingly, the Department of Energy has a mandate in the US to protect the human genome from mutagenic effects of radiation. And so in 1979, Los Alamos had a sequence database looking at the human genome. because how do you know if you've had an effect of radiation has been mutagenic if you don't know what the genome looks like? And by 1982, that had actually morphed into the GenBank. How did they get there? Next slide. So they pooled the data and they coordinated efforts. There was an actual initiative to map the human genome. Congress funded NIH and the Department of Energy in 1988 to go after this goal. And there was a memo of understanding to coordinate the research and the technical activities. DOE did the coordination and the organization, and NIH funded labs did the actual mapping. Next slide. And this opened enormous new areas of research. So genotype to phenotype link, NIH actually has a genome-wide association studies. This is a data success story. We opened areas like proteomics and the ability to identify COVID variants, attracted new funding to the field. I've heard people say that it basically transformed biology from stamp collecting into an exciting and modern science. Next slide. And so other areas took note to broaden the scope. In 2007, Congress passed the America Competes Act that reauthorizes NSF and included data sharing provisions. Next slide. And in 2011, NSF put a hard stop into proposals. You must have a data management plan. This brought this to a lot of attention of the NSF researchers. Next slide. 2013, there was a memorandum for the heads of executive departments and agencies from OSTP saying, you're going to do this. And it got even more global momentum. The Australian government, the Australian Research Council also said, you know what, we're going to do this along with others. Most of you have probably read or are at least aware of the relevant portions of NSF's PAPPG. So I won't belabor it. Next slide. And indeed, most of you have submitted a data management plan, but fewer have actually shared their data, with a large percentage noting that it's complicated. So what's making this complicated? Next slide. As you know, part of this is the breadth and types of data. Protecting human subjects is a challenge. Protecting sensitive sites is a challenge. Next slide. In addition, it's difficult to share physical specimens, as Kirsten knows. And it's difficult even for communities to decide at which stage data has actually been created. As Steve said, at what point do you have data as opposed to readings from a sensor? Is it raw, cleaned, transformed? How do you do version documentation and control? Next slide. So when we asked you what you thought the 3 greatest bottlenecks you experienced in your workflow with data, turns out you're well aware of these complications. This is not a new problem, but it is a problem that you have to engage if you're going to make the leap to large. As I say, the good news is there are actually people who can help. The next slide. As you make the leap to large, you're likely to be working with multiple communities, and they will have different community norms. You may be used to working with a discipline data repository or a particular institution data repository. You'll have to negotiate and come to agreement in the team about where the data are going and why. You're going to have to negotiate the data ownership rights and responsibilities. These are large multi-institutional collaborations. And the challenge of limited facilities and funding, making sure that you actually cost this out appropriately and put those funds in the proposal. Thinking about including a data manager and making sure that you've got sufficient data workers to be able to do the work that you need to do. Next slide. The community knows that it's complicated and has actually developed a lot of tools to help you. If you Google data management, you get 71 million hits. There are a lot of resources out there for trying to build these in. One last caveat in data management on the next slide. Keep in mind that there may be helpful organizational resources. They can also be problematic organizational resources. Remember that NSF makes awards to organizations, and NIH makes awards to organizations, not to individuals. You as a PI are an agent of your organization, and you are doing the work on behalf of your organization. That means the organizations own the data that you collect. So you need to coordinate with your organization in working out these agreements in your team. So you need to be aware of what kinds of IP agreements your tech transfer or legal office is comfortable with. What do they feel needs to be in the data use agreements? Do they have a standard MOU? Because, by the way, you may very well not be authorized to sign any of these things. Often
And
it's the.
by the way, I'm going to just make a quick comment, Susan. As Kirsten knows, one of the early surveys we did of stakeholders around data sharing, in an open field response, one of the respondents said in this proprietary view, he said, if you want my data, you can pry my hard disk from my cold, dead hands when I'm gone. And
I certainly understand that. I also know of a case of a PI that was lured away to a different university because he had this awesome data. And the university he was coming from said, fine, you can have the PI, but you can't have our data. This is our data, not his data. And so these are issues to navigate and negotiate before you actually submit the proposal, because you do not want to run across these legal barriers. They think of them as sort of landmines you need to be taking a look at and making sure that you're not overstepping your legal capabilities. And often, I mean, there are IP agreements. Faculty members know generally are not as aware of the fact that the university actually owns all of your IP, everything that you create. My university says, well, yeah, technically, but we're just going to give you back copyright on your articles because we don't want to go through the hassle of having to manage that. Go ahead and sign the copyright agreement because that's just too much for us. We don't think that's actually valuable anyway. But it's the university that decides whether or not to pursue a patent on your work. And so thinking about making sure that you've brought your organization into the conversation and you know what you can and cannot agree to with other people in the large is a really important step here. And talking to your research computing people, do they have storage, backup, computational resources that you can make use of? Do they have an agreement already with AWS and they get preferred pricing? Make sure that you've actually talked to them about what they have and what you will need before you put the proposal in, because trust me, they hate it when you come back and say, we've got this money and we're going to have all these data that you're going to have to store for us. What do you mean that's going to cost money? Well, we didn't put that in the budget. Talk to them early. Your library also, your academic libraries may also have some storage capabilities depending on what it is you're storing. They may store open repository, papers, software, some other types of things that they generally can't store really large data sets, but there are other things that they may be able to store. So you need to coordinate with your organization. You need to coordinate with your team members. And the data management plan brings all this together as an opportunity to really work out who's doing what and what this team is actually going to be accomplishing and how. And now I want to turn it over to my colleague, John King, to talk about data leadership.
Thanks, Susan. So next slide, data leader. This is actually a topic that has been around for a long time. Modern science and engineering goes back about 4 centuries. And new to the game is computation. That's an important thing. So we're going to talk a little bit about that. We're going to talk about the stakeholder perspective. Data have always been important. They're still important. We've been building up to this for a long time, for decades, in data sharing. And one way to simplify this, because if you want to move to data leadership, you probably are going to have to simplify it a little bit, is to talk about cost savings and the vision. And if you want to do a simple and quick assessment, payers and users as stakeholders is a good place to begin. Next slide. Okay, one of the oldest chestnuts in science is this one. The data that were collected by Tycho Brahe went together with the theory that was created by Johannes Kepler, and that created modern astronomy. And as you can see, this was a long time ago. From modern astronomy came what we now think of as modern science or modern engineering. This is not going away. This is a very old concept. Next slide. Now into that important development comes computation. So 4 centuries ago, we established this idea that you have to bring data and theory together to have modern science. In the 20th century, computation entered the picture, modeling, simulation, and lately, data science. So it's very crucial to understand that we're talking about expanding the role of data. Data is becoming, in a sense, more important. Now, one of the things that's happened here, this was a slide that you saw at the beginning of the workshop. This is openness. The old open was scientific publication, and beyond is open. There's open literature in the sciences. And so everybody's free to read the articles that somebody else has written. That's been pushed back to results and tools and data. And what that's done, in effect, is open the discussion to new stakeholders, other researchers, the regulated, journalists who want to explain this to the public, citizen scientists, and so forth. So this is partly a broadening participation thing, but it's also bigger than that. Now, when I say that there's been decades of sharing, I want to start at the bottom and go to the top, because what you understand is there's a chronological order to this, but there's also an order of discovery. And I want to go with the order of discovery. So first of all, if you go back down to the bottom, here it is, 2021. We see all these organizations, Kristen's organization, Steve's organization, you know, what Christine is talking about, all of this activity around consortia, around standards, around repositories. This is new, and it's not going away. It's going to be here for a long time. A lot of this can be traced back to a key turning point, which was 2013 in the Holdren memo. This was the OSTP. It was kind of like an executive order. It wasn't a law. It was built on the America Competes Act, which Susan mentioned. But basically what it said was everybody who funds science, all the federal agencies that fund science have to pay attention to increasing sharing. One of the things that happened in this memo, which I think of as a disservice, is it said that this is going to be cost neutral. This is not cost neutral. This costs money. If you want to do it right, it's like everything else, it costs money. This can be traced back somewhat to the 1998 Shelby Amendment. And many people think that the idea of sharing is primarily motivated by all of the benefits that people get from sharing. Well, actually, the Shelby Amendment said you can use the Freedom of Information Act to find the origins of the data that were used to regulate your industry. And regulation of your industry allows you to go look at the data, the original data. This built upon the Bayh-Dole Act of 1980. Many people don't understand one of the crucial changes that the Bayh-Dole Act made was the data no longer belonged to the investigator. The data now belonged to the institution. And if the institution is ordered to put up the data, they have to do so. Now, the Bayh-Dole Act also changed some important things about who the owners are. The institution is the owner of the data. They can benefit from the data. That's why they're interested in patents and copyrights and so forth. And then finally, if you go all the way back to 1974, you find the National Research Act. Most of us remember this act because it institutionalized the requirement of institutional review boards. So this was a human subjects issue largely. But the important thing from the National Research Act is the golden rule. The one with the gold makes the rules. And what we see going forward is that increasingly it's the institutional, the owner of the data who makes the rules. This is not going away. So there's two quick ways to think about this. One is cost reduction. So clearly people who are regulated are interested in reducing their costs. People who believe in reuse of data are interested in sharing the wealth. People who are interested in faster exploitation, like translational science, for example, are interested in reducing the cost and getting faster to the returns. But there's also a vision that comes into this, and that's an important component of being a data leader. Broader participation is one of the things that making data available to people, making software available to people, making models available to people is predicated on. A lot of this derives from the open source software movement. There is a desire to more fully capitalize researchers, that is making more research happen with the same investment. And finally, users become operators. That is, they teach each other how to use the data and they engage in network effects. Next slide. The quick, and I would call it somewhat dirty, but it's pretty effective assessment is to say that there are payer stakeholders, and they're going to be interested in two things: reducing costs and getting to the return more quickly. And there are user stakeholders. These are the people who benefit from the data. So if you ask yourself, next slide. If you ask yourself what in these data impact areas, in these 4 impact areas, outcomes of research, the stakeholders will align on cost or on the broader vision, you're probably going to answer the question of what do we need to pay attention to? With that, I will turn it over to Nick.
Yes, and we're going to do everyone's favorite portion of these activities, the poll question. John, just a little side note, I learned a different golden rule when I was young. Yeah. It wasn't who has the gold next to the one.
Yeah, I hate to say it, but there's more than one golden rule.
So if we could get on to the first poll question. It should be popping up for you. You want to make data in your project fair, right? Findable, accessible, interoperable, reusable. Which of the following is probably not in the spirit of fair? The first one, the PIs agree ahead of time for the procedures, curating, loading, verifying the data in a repository. Second one, insist on an embargo period where the data is not released publicly. Third one, publish the data set to a domain-specific repository. And then the final one, charge a fee to cover costs for providing the data.
And we have quite a few responses in. We're now about at 150. I think I can safely, we're getting closer to 200 responses. I think I can safely end the poll because the results are quite clear.
All right, we all jumped on to, now some of you fell for the insist on an embargo period. That's perfectly within the spirit of FAIR because, FAIR, we want all of this, but at the same time, researchers should benefit from it. But if you look at the charging a fee, it's not in the spirit of FAIR, but it's totally consistent with NSF's policies. We can charge a fee to cover our costs. You know, oftentimes if you don't propose costs associated with making it available, there are still costs incurred. So you need to deal with the cost issue somehow. But yeah, the spirit of FAIR is certainly not cost. And you know, there are issues, you know, with charging costs with grad students, emerging nations, and a variety of other issues when you start charging costs for your data. So
Okay.
question 2. We want to be sure that the research team gains academic credit for their data. So these are some tactics. Which tactics should we follow? Publish a paper with the DOI quickly, and then have the data manager be accountable for making the data set available. Make the data available in a domain-specific repository, a DSR, and be sure a DOI is assigned to the data in the repository. And then host the data on as many free and paid research repositories as possible to increase the likelihood that it will get used and cited. So how do we get the team credit?
So the responses are coming in. We have about 100 so far. There's an interesting pattern emerging. We're now getting closer to 200, although I think people are still voting. We'll let the polls stay open for a few more minutes in few more seconds in California. And now I think it's time to take a look at the results.
All right, so you got this right. Okay, there are if you don't have a domain-specific repository in your community, it should be being built, right? It should be being made, or you can lead it, right? It is happening. The first one, it's funny that there are so many results for the first one, which is publish a paper with the DOI quickly, and then puts have that note saying contact the authors for the data, and then make someone responsible for it. That's not the appropriate way to go about this, right? I think that's what we do, but the appropriate way is to find that repository, and there are general repositories. And you know, this is an emerging field. There are DOI, you know, some repositories will automatically assign the DOI. And then of course, putting it everywhere is probably not the best idea either. So final question. Oops. And you know, we suggest that there should be accountability. Before the project starts, we assign the Texas team, or you know, a team, one of the co-PIs, with the duty of, right, for the best example for accountability. The first one is the Texas team maintains the repository, monitoring contributions and ensuring data quality. They will figure out how to follow what they see as best practices, and their organization will provide the space. Second option is the Texas team will investigate the most appropriate public repository, plan for an embargo period, develop and maintain data standards for different types of data and metadata. And then the final one, Texas team will assign a data manager to plan and govern data processes. They will agree on the repository, the embargo period, data standards for different types of data and metadata, and procedures for collecting, storing, and documenting the data before we submit the proposal.
Well, results are coming in. We're at about 150. They're coming in more. We're over 200, and I think the results are clear. So here we go.
Yeah, so you got that right. The key is this. The first two are, at least in my experience, what I've probably done and what I've seen is, you know, we'll take care of the data management. Here's a couple paragraphs in our data management plan, and we will figure out procedures. We will figure out standards. We're going to, you know, it's vague and it's accountable to a group. In actuality, for a large scale project, there has to be a role for a data manager, right? And the data manager is going to lead the effort, but before you submit the proposal, you want to do as much work as possible on figuring out which repository, figuring out the embargo period, you know, everything you see here, you want to do at the time. You should have made these agreements for the most part.
And I'll add one thing there to kind of follow on to an earlier comment. It's actually much more expensive to do this well than most people think. So it pays to engage this early and get some sense of the costs before you write the data management plan.
Super. Well, Nick, we know people like your polls, and this one, again, helped to reinforce the lessons to learn. And we're actually right on time for our keynote speaker. Do we have Casey here?
I saw her before, yes.
Yep, I'm here.
Oh, wonderful.
All right, so wonderful. It is my pleasure then to introduce Dr. Kimberly Claffey. Dr. Claffey is founder and director of the Center for Applied Internet Data Analysis. It's an organization known as the oldest and most recognizable research institution for global internet measurement and analysis. So she leads the organization's research and infrastructure efforts in internet cartography, aimed at characterizing the nature of the internet's topology, routing and traffic dynamics, and investigating the implications of these changes on network science, architecture, infrastructure, security and stability, and public policy. So Dr. Claffey is also a research scientist at the San Diego Supercomputer Center, UC San Diego, and an adjunct professor in computer science and engineering at UC San Diego. And in 2019, she was inducted into the Internet Hall of Fame for pioneering work in the field of internet measurement and analysis. So please join me in welcoming Dr. Claffey.
Thank you. It's an honor to be here. I'm just going to give a short talk here on my experiences spending pretty much my whole career in the data trenches. You can do the next slide. So I've been a leader of 4, I think you fit them into the large category here, NSF funded efforts in the last 15 years. They've all been focused on data. So something that I come from a slightly different perspective, and that I really, I'll explain in the next slide or so, my religious conversion to data management and data sharing. So these have all been focused on improving the integrity of scientific internet research using large-scale macroscopic, that is, try to measure the global internet data sets, which of course requires not just the data sets themselves, but tools for analyzing, querying, interpreting these measurements. We've been fortunate, and through lots of hard work, have had lasting impacts beyond just the academic sector, technology transfer, including a data sharing consortium, a nonprofit that still exists. They bring researchers and operators together to introduce researchers to important questions where they can have an impact. By pursuing answers to those questions, they expose operators to results of research that would be relevant to operators. In fact, their next meeting is tomorrow night. They have meetings several times a year to do this. It's called DNS OARC, focuses on the domain name system. So that's one example. As the years have gone by, there's been increasing interest in governments and policymakers having better insight into what the internet looks like, the dynamics, the behavior, and more recently, a need for third-party independent measurements of various internet properties, structure, dynamics, security aspects. Another, I think, lasting impact, and maybe the most important for this audience, is all of our data sharing agreements are online. They're all open source. And I'll talk about a project that helped us get them sort of more formalized over the last 10 years. The most gratifying part of this kind of work is that it really has a democratizing effect on the community and on science. That's true for any field, but it's been great. I think internet research in particular is too important to be a spectator sport. So we've had over 80 data sets. Some of these are many of these are longitudinal data sets, so they last 10 years or more. Has enabled over 2,000 papers with many tens of thousands of users. That turns out to be tricky to count based on the way we share the data. I'll get into that a little later in the talk. So if you only take one thing away from this talk, and it's been hinted at earlier in the sessions, earlier in this session and even previous sessions, is don't try to do the data management piece of this alone for a large project. Now I know I'm coming at it from a perspective of where the whole project is, well, much of the project is focused on data management and data sharing, but that's going to be, I think that data management is going to be a big piece, and it's getting bigger. There's getting more awareness of the importance of data to science and having a more formal approach to data management and data sharing. So there's so many aspects to this, not just what's the format of the data, how do you store it, how do you document it so that people can use it, but how do you make it accessible? We've been talking about the FAIR principles all morning. I'll talk about a rich context catalog later here. Now there's an increasing momentum in the privacy community to develop pretty complicated technologies for allowing data sharing without data sharing, allowing access to data, differential privacy, secure multi-party computation. There's a dozen different technologies that are emerging, and there's been a barrier to really uptake of those kinds of technologies in different fields. But I think that there's going to be increasing interest in closing those gaps in the next decade or two. And then finally, privacy frameworks, policy frameworks, ethical impact assessments, ways to really think about the implications of the data that you share and how to maybe modify the data to make it more amenable to sharing. And I'll mention this a little bit later in the talk as well. So my history is that I had a bit of an epiphany in grad school because I had the opportunity to do, you would not call it first, but it was one of the earliest pieces of science on the internet. And the reason I had that, many people may not be aware that for the first 30 years of its life, the internet was really a government project, administered, funded, managed. It had, contractors, but it was really the US government. Indeed, it was originally a Department of Defense project that sort of outgrew itself. It was a victim of its success. In fact, the National Science Foundation came along and really, I would argue, made the internet possible because it covered that gap between when it was a military project and when it was privatized and commercialized in the 90s. So for that 10-year period, the NSF managed a backbone that connected up all the universities in the US and including pushed toward international coverage, helped the international community grow. And that was the year that I did the decade that I did my thesis, my PhD thesis. In fact, the year that I was writing my thesis, the World Wide Web was invented. So I had this little graph in my thesis where the y-axis had an exponential line. It was port 80. And I thought, I wonder what that is. Now, it was pretty well clear what that was by the time I graduated. But the other thing that happened when I graduated was the year that the NSF, in a very careful piece of industrial policy, I would say, decommissioned the backbone in order to escort the internet to the private sector and allow the 1,000 flowers bloom as we saw for the next 2 decades. So that meant the data went away. I was completely dependent on data, public data that was essentially regulated by the NSF to be put on a public website via FTP, if you're old enough to remember that protocol. And the data for that went away because the backbone went away. And so I was worried when I graduated, how is anybody going to study the internet after this? And so after a few years of rumination and thinking, I wrote a proposal to NSF to fund what then was called Cooperative Association for Internet Data Analysis. And now we've rejiggered the acronym, but it's basically what it is today. Next slide. The Center for Applied Internet Data Analysis. And so that's the beginning. That was the sort of inflection point for the beginning of my career. Now we're actually seeing a second inflection point, or an N+1 inflection point, as the government starts to take quite a bit of interest in the internet now and tries to figure out what does it need to know in order to inform policy. So over the last 25 years, we've been data-focused, services, products, tools, resources to advance the study of the internet infrastructure. Now, obviously, now we see there's lots more aspects of the internet that need study. We're focused on the plumbing of the internet. Mostly funded by US federal tax dollars, some industry support, lots of information on our website, annual reports, program plans, all of the data sharing agreements, all of the proposals that have been funded. Really too much information is on that website. In fact, we're overhauling the whole website. So wait a week if you're going to go dig into the website. Next slide. So we share data in a lot of different ways. And so we've had a lot of experience with the pros and cons of just letting people download files, including public files versus restricted files. I've got some graphs on that later. We've also created several interactive data services that allow people to play with the data themselves. This is particularly useful for less technical people that just want to see a table of the top ISPs on the internet according to various metrics. But researchers really need programmatic access, so that we've developed software frameworks for analyzing internet routing data, called BGP Stream is one of the well-known ones, and then APIs. So we've spent the last 5 years basically creating APIs to every data set that we have available so that people can integrate it into whatever data framework they're trying to build. And that's been challenging, but also driven by community feedback. We also allow some of our infrastructure, our measurement infrastructure, to be directly accessed by researchers. Now, most researchers, frankly, would rather have the data, especially if you're going to curate it for them in a way that they don't have to deal with all of that, because they want to study something at a higher level. And so they're happy to have there be a canonical data set. But some people actually need to run a new experiment. And so we have a measurement infrastructure where we allow, indeed, various types of access to that measurement infrastructure to do scientific experiments. And then finally, there's some data that's either too sensitive or too large in volume to have a researcher download it. And so we have a sort of code to data model where we have an enclave. It helps to be at SDSC, where you have a HPC resources and lots of people that are focused on data like Christine. So we have our darknet, or sometimes called a network telescope, where we have researchers come and log into a machine. Next slide. So metrics are really important. Metrics are tough, For data management, data sharing, sort of what have we achieved for the community? I think funding agencies are really used to the canonical paper count metrics, but citation count. I think it's harder with data. In particular, like with users per year, if you put data up on a public website, you're going to get many thousands of IP addresses, especially if it's data about internet infrastructure. You're going to get automated robots downloading that data. So although we have 70,000 unique users per year at the top of the slide, because we made some data public last year, some older data public, it's tricky to turn that into really how many users are downloading that data. However, for much of our data that's restricted, you have to do a handshake with us. You have to say what you're going to use the data for, where you're from. We have different approaches for commercial use depending on the company and the type of data. And then we all have to go through export control processing now with the university. So it's actually pretty straightforward. They have a great framework for doing it, but that means there's definitely work on the end of disseminating the data. But other metrics we do ask, we cannot enforce, but we do ask that people report back when they publish a paper with our data, and lots of people do. And then we do the proverbial Google Scholar search and just website search for DOIs and for data set names. But that's tough. I mean, managing sort of the accomplishments of your data sharing efforts, I'm not going to say that's trivial. And I think to the extent that you can lean on what other people have done, I highly recommend it. Next slide. So what we've also done, because the feedback that we've gotten from researchers in the last 2 to 3 years is, okay, you've got a ton of data. Now make it easier for us to use it, because my student downloads a data set, they don't know how to get insight out of it. So can you add little code snippets so that they can, at least get started, and then they can modify the code. And so we're doing that. In fact, we have a very prototypey catalog.cada.org. If you go to, again, we studied all the rich context data catalogs that have been gaining some traction lately, but it's hard to reuse the kind of software from other projects. There's so many domain specific aspects, including metadata and data formats of data itself, how you want to link to different aspects of media. So I would say this is super beta experimental right now, but we've learned a lot. I think it would be great to have such a thing, not just for CADA's data, but other internet domains. So you guys have talked about domain-specific or discipline-specific repositories. I wouldn't say that our field has one yet, despite it being, well, you could say 20 years old. That's pretty young for a scientific field, actually. But we're trying to prototype this in hopes of maybe we can develop one for the community. Okay, next slide. It would be remiss of me not to say a minute about the inevitable conflicts that we have between, everything surrounding data sharing, especially with the internet infrastructure, especially as it privatized. Again, one of my motivations was, well, the internet's going to be mostly operated by the private sector. There's a lot of sensitivity with respect to sharing data, not just for commercial reasons, but national security, critical infrastructure. There's obviously privacy concerns, and now lots of legislation is popping up around the world to try to address that issue. So we have a blog where we talk about these things from time to time. But this is a big issue. And again, my advice would be try to reuse what you can reuse from other fields. So next slide. There was DHS. DHS is Department of Homeland Security. They funded quite a bit of our work. In fact, after the 9/11 attacks 20 years ago, there was increasing awareness that we can't secure what we can't measure. And we really are behind on our ability to understand the internet for various reasons. So they built, in order to really validate a lot of the security research that they were funding, they built a framework for sharing cybersecurity data to allow that validation. They built a distributed repository. So the researchers or whoever owned the data still held the data. The DHS had a contractor that managed the metadata framework and the centralized legal functions, so all of the legal agreements, which we're trying to move the ball forward with respect to these FAIR principles and also with respect to the integrity of security research that they funded. So lasting impacts of that, and the last 2 slides here are, again, all the data sharing agreements are open. I can put a link to those data sharing agreements. Those were written by lawyers. Now ours have sort of built on top of those. So now you could say that ours have been blessed by lawyers, although for the first 15 years we were rolling our own. We were getting input from the IRB and things, but we didn't have legal experts. Now we do. And again, they're expensive. So we leaned on DHS for that purpose. I encourage you to use what's already out there as much as possible. Not that I'm giving legal advice, but they're a good place to start. And then finally, the other lasting impact from this project, the DHS project, if you don't know about it, I recommend it, although it's more focused on the ICT. You probably all know about the Belmont report. So the Belmont report was in 1979, was basically what gave rise to the institutional research boards in the US. And IRBs. And we, 10 years ago or so, as part of this project, tried to port it, tried to adapt the Belmont report, the principles underlying the Belmont report, to information communication technology research, including, because some of them maybe you kind of have to get your head around how to adapt them, but we included a bunch of case studies, since it's still a little bit clear that the harms in the ICT space, because the Belmont report is about how to minimize harm when you do research on human subjects. And so this was, well, we don't understand as much about harms as even they did in 1980 from biomedical harms, but we can taxonomize the space, and we can provide some case studies. And so there's two reports, a main report and a case study companion report that I highly recommend checking out if you haven't heard about it. And maybe they'll be relevant, since really everything is ICT research now. Everything is communication technology research at this point. Okay, it looks like I'm almost out of time. So that's the end. But really, I would say that's the beginning. Like I sort of recognize as I get older that we're at the beginning of this field of internet science. There's a lot we need to learn, and we're definitely at the beginning of how to deal with data associated with that field. And from what I hear, many other fields, given that everything has become information science, are also kind of at the beginning. But progress is being made. So I'm happy to take questions.
Oh, yeah, please put your questions in the Q&A and we'll queue them up. But thank you so much for a wonderful talk. This is fascinating stuff that you're doing. I wasn't fully aware of the breadth of what's going on there. Is it pronounced CADA? Or how do you say?
CADA, we say CADA.
CADA. All right, so one of the questions, and there's a ton of them, within the types of data CADA collects and shares, do you see any part of it that could be shared without a handshake with the users? What are your viewpoints of the many sharing and experimental network traffic that are easily downloadable from various sites on the internet?
Okay, you have to tell me examples of the second one. Put it in the chat. I don't see the chat that you're...
Well, this is Q&A that we're talking about.
Oh, here. Do you see any part of it could be shared without a handshake? Lots of our data is shared without a handshake. You can go to our data page, www.cada.org/data. Now, again, we are in the process of overhauling this whole thing, so it's a bit 1990s, our website right now. But and you can look, and there's a column that says, is it public or not? And so there's lots of data that's public. In fact, that's where the 70,000 number comes from on IP addresses. And indeed, we do go through a bit of this privacy impact assessment. What's the harm of sharing data? Is it okay to share data older than a certain age? That's how we got to sharing a lot of data. So for example, older than a year, some of our topology data is public. And we do go through a thought process there, and we document it, and we talk to IRB folks sometimes. Now you had another question about the open. None of that is traffic data, mind you. Traffic data is sensitive. In fact, we have some traffic data that's all anonymized, and I should have mentioned this earlier, not only is it anonymized, because our field learned the hard way that anonymization is not sufficient, because there are security and privacy researchers that sometimes think it's cool to prove that they can de-anonymize something and get published that way. So no. You have to have anonymization and a policy framework that's a code of conduct, effectively, that says you will not try to de-anonymize this data. Now, again, we can't enforce it. Things go wrong for the whole field. Nobody will ever share data again. In fact, a little bit of that pullback happened because we weren't the only one well, it didn't happen to us directly. It happened to some colleagues, but it's also happened in industry. I think the Netflix data sharing was a famous example. So traffic data is a different thing. Again, doesn't mean you can't share it. You need different models for sharing. The enclave, where you bring the code to the data, you bring the research to the data, is a type of traffic data that we share. It's not two-way user data. It's a different type of data I can go into. But in that case, it's going to be more common to bring the user and have a policy framework around that, bring the user to the data.
Yeah. So there are a whole bunch of questions just asking your perspective on things like, why did you pick a BSD4 license for data sharing? And how should one pick a license? Like, what's the process by which you're going to pay it?
Okay, yeah, we have to be careful. We don't use BSD for all of our data. In fact, I'm not sure we use BSD for any of our data. Let me know if you see something like that on the website. We use BSD for some of our software. And again, you have to think through what is your objective with sharing whatever it is you're sharing, the resource that you're sharing. Because BSD is good for some objectives, not good for other. GPL is good for some objectives, not good for, this is really associated with software. Our data tends to be licensed per the university's open source license, and then commercial use is a different matter. But this is also a moving target. In fact, even the university is changing how it thinks about, is it a data license or is it a service agreement to get access to the data? And these things all have different answers depending on not only the data types and the risk associated with sharing it, but the use case for it and who's using it. So I unfortunately don't have a clean answer to that question. It's not all BSD.
So another question is, what's your take on RDA, right? The Research Data Alliance.
Unfortunately, I'm not familiar with RDA. I mean, RDA is around in the last 10 years, and we were doing this for the last 25. So by the time RDA came around, we had our processes pretty well underway, and we were working closely with DHS. So the one thing I will say is that I don't remember there being a big focus on security, like cybersecurity aspects of the data, which we were very focused on at that time. But I'm embarrassed to say I don't know enough about RDA. I'm sure it has great value. I just need to learn more about it.
Another one, do you use any make data count standards in your metrics?
I think I don't, because I don't even know what that is. So
all right, we'll skip that one.
Somebody send me a URL to that so I can go learn about it.
All right, yeah, someone post a URL. So let's do one more. Actually, I don't know where the question went. It was about FTAs, like how many you dedicate to, I guess, FTEs.
Yeah, full-time, you mean full-time employees?
Yes.
Yeah, this is a great question. I again, not a clean answer. It's a part of a bunch of people. So when I say dedicated team, I don't mean you cut the person out and they're only that, but I mean a dedicated function. And yes, definitely put that in the budget. And you're not going to have enough money, even if you put it in the budget. I mean, I've got this theme going, but I think even the funding agencies, frankly, are starting to realize just how expensive it is to share data in a way that's fair, reusable, accessible. And another piece of tension is that you want it to be reusable, but sometimes your data is collected under the auspices of, if you're going through an IRB, that you're going to use it for this specific purpose. And it doesn't mean you get to use it for, it doesn't mean you get to use it for something else, never mind sharing it. So that, again, lots of properties of this.
So real quick, what you just said about the role, I know that one thing we strongly recommend and NSF recommends is that you hire a project manager. So that's a full-time human being. But with data, it's less often hire a specific full-time human being. More you create a role or two or three, and those roles are responsible. And sometimes people move in and out of those roles as graduates. Can you speak a little bit to that? Like,
yeah, we have a full-time project manager and a full-time data administrator. We have a lot of data. And there's a lot of people that want it. So, and even that is probably not enough. And of course, we're academics like all of you all. So we end up, it's hard to keep those positions funded. It's hard to keep those people from going off to industry because you can make much more in industry doing essentially the same thing. And then we also have sysadmins, DevOps people associated with building the infrastructure to share the data, to do the data dissemination, to answer questions about the data. So it's more than one full-time people. It's probably it's one full-time person and it's probably part of 4 others. Now, not every project is going to be so focused on data. In fact, for much of our projects, there has to be a research component because until recently, it was almost impossible to get data, at least for me, it was impossible to get funding just for data. So we would, more or less do some research and then focus a lot more on data than most projects, because again, I had this epiphany. I was like, get the data out there. We can't do all the research ourselves. We need to really create a field here. Yeah. And work in progress. So
again, we're totally out of time. We went over, but it was such a fascinating discussion and we really appreciate
Thanks.
it.
I'm happy to answer questions. Casey@cata.org. I'll put a couple of links in the slides. There is an NSF Dear Colleague letter out about data. I'll put it in the slide deck. I'll put it in the chat. I encourage folks to read it and maybe respond. And thanks so much for the opportunity.
Wonderful. Thank you. Joel?
Super. Well, first, let's join in a round of virtual applause for Casey. Thank you so much. That really was the capstone of today's session. Deeply appreciated. And it was accidental, but we ended up having a strong San Diego connection with a number of our different folks on today's program. But I appreciate your work with Christine as she is part of the infrastructure that supports what you do. And in fact, if we could take a minute, Christine, do you just want to say a little bit about the handshake that you have with KC?
One of the reasons I love working at the San Diego Supercomputer Centers, you have researchers like KC who push the bounds of what would be possible and be allowed at other universities. For example, how close we're allowed to plug into the edge of the network because of KC's internet research. KC's questions on data at scale and how to share out, how do you share out, a petabyte of data because she has, I mean, I think she just scratched the surface on what her research is about, but she has data. For example, if you see a country knock off the internet, you can go to her telescope and say, oh yes, that's exactly when it left, and watch for it coming back. But I would say I just really enjoy the challenges that Casey's research brings up, and rising to those challenges has made me better as a research computing person.
Super. And a final word, Casey, on your other side of that handshake.
Yeah, again, I probably wouldn't have this career if I didn't luck out and end up being at SDSC, where there was already all these experts there, and UCSD has also been really supportive. So, but again, to the extent you can make use of things we've done, please ask me. If you don't see something on the website, let me know, because we're happy to share. It's all been mostly funded by the taxpayers, so we wanted to have impact.
Super. And again, thank you. Well, just to wrap up this session, we did ask you about your experience with data, and I just wanted to share a couple of your comments. We asked you, is there a high degree of cooperating around the sharing of research data in your field? And on average, you said it was a 4.7 on a scale from 0 to 10, with 0 being strongly disagree and 10 being strongly agree. Not very good. There's work to be done in many fields and disciplines. We said, what about the sharing of software tools and methods? You said that's a little bit better, but still a 5.8 on a scale from 0 to 10. We asked you, how about data storage and computational infrastructure? Again, a 5.2 on a scale from 0 to 10, work is needed. Then we said, well, is there enough knowledge in your field or discipline to reduce the burden and make it possible for people to share? And you said that was bad, 3.8 on a scale from 0 to 10. And then we said, well, what about the 10-year promotion and reward system in your organization? And you said it was a 2.4 on a scale from 0 to 10. And so essentially what you're saying is that the institutional arrangements haven't caught up with the work itself, with the need to support the sharing and reuse in the ways that Casey and that our panel and that our own presentations have been highlighting. It also suggests that there are some pain points around building knowledge, building skills, building storage, building mechanisms to reduce the friction in sharing. The last thing that I'll say as we wrap up is we did ask you, well, what's your vision of success around the sharing and reuse of data? We just picked a handful of the hundreds of comments that you had. But first you led with protecting human subjects. You talked about the importance of expertise and curating data, but co-designing those with the researchers. You also said that it gets harder at scale, and I think we had a taste of that today. The importance of metadata, the importance of ethical conduct. You also talked about kind of an on-demand or pull-based model for data, but of course, safe, secure, accurate, and de-identified, and KC talked about that. You highlighted frictionless sharing, and you did say that sharing is caring, society advances. Not only does it do progress in science, but it literally has to do with the success of life on the planet. And lastly, one of you observed that data is born to be free. So that's a little bit about what your lived experience is. Let me turn to Susan to look ahead to the next two sessions.
I just have to say, when you say data is born to be free, do you mean like free speech, free beer, or a free pony? Because sometimes there's some maintenance and upkeep if you get that free pony. So yeah, this has been a great, really interesting, lively session on data. We've got 2 more sessions. Next week will be workforce. We'll talk about teamwork and broader participation. The week after that will be collaboration, focusing on collaborating across fields and disciplines. Of course, they're going to be related because teamwork and collaboration and broader participation are all kind of interlinked. So we look forward to seeing you next week. And thanks again to all of our great guests this week.
Super. Again, big round of applause. Thank you to all. And we look forward to seeing you next week. And don't forget to complete that pre-session survey. It'll be the last one.